Recently, I wanted to measure electricity from a little generator. Not negative, only positive voltages. And I wanted to show it in real time on a diagram. And the whole thing had to work underwater, which isn't ideal for this type of generator, but it still works. That's because this generator is actually a brushed motor, and they can function both as a motor and a generator, because they're so simple, and they work even underwater. I tried a multimeter, but I guess they're really not made for any job underwater. What should I do? There goes another one. I just want a diagram. Can't I just buy something? That's a whole computer. What if it breaks again? I don't want to produce trash. Okay, a little bit can't be avoided. I didn't find a good solution, and so I built one. Here it is. Now the measurements can be done underwater. The voltage gets plotted over time, and the maximum and average for the last second is displayed in the bottom right corner. I have a battery with a button, so I can switch it on and off through the silicon case. It doesn't take as long to start as a computer does, because instead of a computer, I'm using an Arduino microcontroller. Creating a user interface for the Arduino is different from creating a user interface for a smartphone or personal computer. You can't just plug in a sensor and display. It consumes much less power, but it's working without apps, pre-installed drivers and operating systems, but instead, you get direct control over the hardware. And unlike a personal computer, it can't handle many things at the same time, because it has only a small processor and no graphics chip. So everything has to happen in one single loop or task. So that means with the Arduino, I have to directly overwrite individual pixels on the TFT display, because there is no graphics card. This type of display logic can be so slow that we can see it. Check out how the lines get longer when I increase the horizontal space that shows 1 second. The lines get longer because there wasn't enough time to paint over the old pixels completely before showing a new value. It would be more precise to show just 1 pixel for that data point, of course, so I made this example. But in the end, a person is going to read the diagram, so some design and technology trade-offs have to be decided upon. And at least I can read the lines much more easily than the dots. Even at the level of this simple diagram, a good balance between design and technology needs to be found. The code is open source, so when you see this video, your Arduino might be quicker or slower, your display bigger or smaller, and very likely your needs will be different. So I wish you happy experimenting, designing and programming.
Das gibt es doch nicht.